Welcome again to CS372. This is the final lecture of this quarter. And before the lecture, I did a survey asking what topics will be of your interest. And Awush suggested I should cover privacy preserving machine learning. And I think I agree because privacy preservation is an important topic. And you must heard about GDPR. This is the European Privacy Act. And in the medical domain, we have had HIPAA for some years. And California last year passed and also put into practice CCPA. And one important element is not only you want to allow user to do explicit opt-in and opt-out certain items, right? And you have to be able to prove you have done so. And a lot of time, a company can just say, yes, this is the policy we have informed the users, and yes, they can press the button to opt in, opt out, but you have no idea what's really behind the screen. So the key is must be verifiable, and the company need to prove in the court they really have done what they have promised. So the details will be covered in today's lecture. And let me make two announcements. And our final project presentation, we have scheduled via the Slack channel. And make sure you are present next Wednesday. And I'm looking forward to a wonderful presentation of yours. And regarding a project suggestion, put all our lecture material together to develop a caring agent. For example, we do healthcare caring for elderly in the nursing home and building a robot using the technologies we cover, like virtual assistant, but making the dialogue between a patient and a caregiver a really caring. As we said, loving means you make another person a better version of him or herself. And I would put materials together and we can work on this interesting project as an optional project in the summer. And now let me project the slides of today and let's get started. Okay, today's outline, we are going to cover the major concerns about privacy from users' perspective and also from companies' perspectives. And the privacy regulations, the key regulations are CCPA and GDPR, and we plan to explain them in details. And also in the medical domain, right, we have another set of regulations, but they are pretty similar. Then from these compliance requirements, if we cannot comply as a company, the company may be fined heavily. So we have to understand the compliance requirement and convert the requirement into execution requirements. And we must have heard about like federated learning or differential learning. Will those implementation fulfill the regulation requirements or not? I personally consider they are not adequate, but it's really hard to say until a company will be brought to the lawsuit situation. The court eventually will clarify the boundary of the regulations. So we enumerate three major technical approaches to be able to preserve privacy. And finally, I mentioned this Stanford system called Soteria. It's co-developed by Stanford and also my previous colleagues, and use this blockchain to safeguarding privacy. So privacy, for sure, we know that they say using cell phone, using laptop, whatever information we enter, we will be tracked, right? So there's a trade-off between free usage applications and you have to give us something. And in certain situations, if you don't give up your information, the application cannot be run, like Google Maps, right? Google Maps, you say, I want to opt out location tracking, then good luck. It just cannot be functioning. So, but other applications like
news. So I'm consulting a Japanese company right now, and they are worried about if they track your reading patterns, what will be the regulation ramifications, right? So in certain applications, the yes or no, between yes and no, the boundaries is kind of tricky. And the self-driving vehicle, for sure, it has been collecting tons of data. And take Tesla as an example. If you see the fine print behind the vehicle, you can see it collects your battery status, temperature inside, outside, your location. Also, in this level 2 self-driving, they have to track the user's status, right? If a user is dozing off, they will just turn off self-driving mode. And all those information, potentially where you are and what is your conversation, even in the car, they will track. And for instance, if you are in, they say, in some countries, you get into a taxi and everything you kind of conduct in that taxi, in that space, is not personal information. It's actually private. And so when we talk about healthcare, we introduced this tricorder device with a number of medical IoTs, and all those information, such as the walking pattern and the ECG information on Apple Watch, right? Those data is being collected and utilized. And frankly, I have no idea who is using my ECG data, and will Apple resell my data to other companies. At this point, I'm just totally clueless, right? So it would be nice to be informed what kind of data is being collected from me, and to which party the data will be sold. And OVO, as part of OVO, Stanford OVO, we're doing this virtual assistant, and virtual assistant will become more and more popular. Even you don't have a speaker, just talk to your computer through Siri. Information is being collected, and all these speakers, suppose we turn them off, they are still sort of listening, right? Because they need to be waken up to perform their duties. So conversations at home will be recorded. So one situation I got into, this was about a week ago. I went up to the dish, and I came home, and I feel my knees were hurting. So I on the one hand, I'm searching for remedies for healing my knees. At the same time, I also talked to my wife about the situation, and suddenly Facebook prompted this video to me. So that was very spooky, right? So this could be one of two situations. One was Facebook through MacBook was listening to me. And the second thing is maybe I was typing something in real time, the information was transmitted to Facebook, and Facebook do this kind of real time matching. So this is, to me, it's a kind of horrible experience. Means, well, in real time, people can target me, or you can say this is a blessing. I have this health concern, and someone is really caring for me. So, top consumer privacy concerns. So yes, I do have a lot of concern. And this is a survey conducted by some agencies, and you can search all these kind of different surveys on the internet. So I summarized some key concerns. One is definitely identity theft. It's not really changing these days. Even you say I want to anonymize myself, but still do cross correlation. If people really want to target you individually, they could get your PI information, personal identifiable information. And the private data then will be made public. And this is really bad for especially politicians, even for us, right? It is not a glamorous situation. And data can be sold and distributed without our knowledge. And certain data, especially medical data, could be valuable. So when data being sold, people will be willing to sell the data for revenue or for charity, but they'd like to know the fact the data has been used. And the safety, if my location can always be tracked, then if people want to impose harm to myself, and that's kind of not a comforting situation. So let's enumerate some details of CCPA and the GDPR regulations. So GDPR was established by European Union, and CCPA was passed by California Congress about 2 years ago. Then was become active January 2020, and they gave all the companies some grace period to implement it. And currently, if my information is not obsolete, means if a consumer asks for certain privacy-related actions to be conducted by the company, let's say erase my access history, the company has to respond in about 3 months. So because the regulation was just out there last year, so therefore they gave this long grace period for all the companies to get their act together. And recently, when you access certain sites, you started to get a pop-up like, can I use your cookie? Can I track your cookie? And so on and so forth. Those are pretty much because of a CCPA. And lawyers agree CCPA, although was initiated in California, but will be widely adopted by other states very, very soon. So like I mentioned, CCPA started last year. And some terms, let's define them. So when we discuss all the implementations, we'll be on the same page. So here we say person, we talk about jurisprudence nature person, just like a person with a body with temperature, right? It's not like a business kind of unit. So personal information defined by information that can identify or relates to, describes, is reasonable, capable of being associated with a real person. Okay. So this kind of personal information could include my address, IDs, and several other things. And we talk about more in later slides. And then to store the data, managing data, we divide the people into kind of two or three categories. One is the people need to manage data, right? Data, we call data subject. And the data controller, it's a person who determine the process of managing the data and set up the SOP, standard operation process, for processing data. And data processors are the people who are instructed by data controllers to process the data. So basically, you have controller and processor. They play different roles. Okay, and PI, personal information, is divided by a few categories. One is personal information strictly prohibited to disclose, including a person's religion, genetics, biometric, healthcare data, and IDs. And there are more. And some data, they are anonymized, right? So suppose you have a database storing a person's name, and then all the personal information plus their access history. Access means, let's say I access a news website. The access history will be all the news I have read in the last, let's say, several weeks. So you like to be able to anonymize not really the access patterns, but my PI, personal information, need to be anonymized. And another category is pseudo-anonymized. So even let's say you anonymize my record, but still using some mechanisms, I can still re-engineering or re-identify that person, right? I will give an example shortly. So basically, suppose I have your address, and that's very, very simple. I have your gender and then maybe your working location. Maybe it's not too hard to pin down your identity, even not yourself per se, but can profile you into a specific group. So this is an example. Suppose you have data stored by, let's say, Facebook or Google, and they need to worry about two things. One is how to store data, and the second thing is how the data will be accessed, right? And the storage, because when you store data, data will be used. So how the data gets stored can affect privacy. So let's say you have your database table, which consists of personal information and like I mentioned, some access history. You have to separate the two into two tables, then do a join. And only data controller can see both tables. And the data processor can only touch on the table with only data history, but without PI information. Okay, so you kind of reduce the number of people who can touch PI information, and even let's say data controller can access PI information, and all the accesses must be logged and log on indelible record for future audit. So here, one important point sticks out is indelible record for audit. And the auditing process must be transparent and must be trusted. And all the actions done by this DC and also need to be provable, right? So you say, yeah, I did it, I did this and that, but that's your verbal claims. But when FCC audits a company, they want to see provable evidence. So privacy governance and policy clearly written to cover the following. So I will talk about GDPR and CCPA separately, but they are very similar. Only about one or two items they have slight differences. So the policy clearly written, just sent to the user. User need to consent. The policy has to cover what data the site collects from the user, and the collection method mechanism, how data will be used, and what the user will receive as an exchange, right? So, for example, you would give more accurate ads as an exchange. Whether you like it or not, you can make a decision, and where the data is being stored, and will the data be shared and shared with whom. So this required information must be stated in the privacy policy. And some consent must be explicitly be given by the data subject. And you cannot just say, I give you this policy with 10 items, and then you say, well, you have to agree with either all or nothing. So the key thing here is that by default, all the items will be opt out. And we have to itemize each collected data item separately, and then there's no bundle agreement. And the user has to click each one of them to say, either I accept your collection of my data, collecting my data, or not, right? So no box can be pre-checked, and the option is opt-out, and the user can come in to select the items they feel comfortable about, and they can always come back to opt-out, okay? So everything has to be done explicitly. That's a key. So unlike currently, many consumer activities, you will be given a huge or huge deck of documents, and you are required to finish signing within 10 or 20 minutes, right? Especially, let's say you buy a house or even buy a car, and the contract agreement, a few pages, and you just cannot see all the details of or fine prints within the pressure timing. Okay, the second information pieces specifically cover GDPR, these European regulations, and the consumer has right of inform, right? Any data being accessed must be told, and the right of access must be granted by the user, and the user has right to erase, to be forgotten, and right of data portability. If I want to move my data from hospital A to hospital B, you cannot say no, you have to let me do it. Right to restrict data processing, and right to object. And data processing you can even be very specific, saying, okay, my gender information or my age information should not be revealed. Right to rectification means I can make changes to my personal information and right to reject automated individual decision making or profiling or even as targeting. And CCPA, as I said, the Bill of Rights are very similar to GDPR, except for two items. So I highlight in red. The first here is know whether their personal data is sold or disclosed, and if so, to whom. Okay, and GDPR didn't say that specifically, but CCPA is saying, well, if your data has been sold, you have to tell the owner explicitly. And this is probably because of a few problems happened in the past years. And I have some examples to show you shortly. And the final one is a little bit dicey. It's called not to be discriminated. And I couldn't understand it until the company Smart News and try to implement the privacy rules. So Smart News in the initial say, well, our privacy data stored in the backend is very convoluted. So if we really need to be in compliance, then we have to redesign the database schemas. We have to do this data unloading, reloading. This will take some time. So why don't we do a shortcut? We just tell the users who opt out this kind of access data agreement. We just say, okay, sorry, you cannot use our application anymore, and basically deinstall their applications from their phone or from their desktop. And from CCPA's perspective, you cannot do that because this means you are discriminating certain users. They are not willing to let you collect their data. But why this is very kind of dicey, because suppose in the situation of Google Maps, right? So you say, okay, I'm not going to allow you to track my location. So you say, oh, then I cannot give you driving direction. That's not really discriminating against you. I cannot serve you because I don't have certain information about your situation. There's no way I can give you a reasonable prediction of your next driving direction. So another scenario, you can say the opposite. Let's say I have this application. I want to charge you for, let's say, subscription fee, $10 a month. But if you allow me to access your data, then it's free. So then if you have this kind of offer, it's hard to say whether you are discriminating against the user or not, right? So all these kind of boundary conditions we can interpret right now, but eventually will be interpreted by the law of the core of the law. So finally, a very subtle point, but it's extremely critical is I'm not going to read this all details. The critical thing is you have to be able to write all your privacy safeguarding actions somewhere, and eventually your actions have to be provable. So give you an example, they say person X requested company Y to erase his or her private consent via email. And company Y did not fulfill the request, but they claim that they have done the request, right? So you say, okay, erase my data. I say, oh, I did it, but actually they did not. So how can you prove it? And you can get into this he says, she says situation. That would be very convoluted. So the law requires the company has to be able to prove they have done all the processes to safeguarding the user's privacy. So let's come back to talk about provability in the end. And these are some landmark cases of privacy policy violation and the consequences. On the top row, you see in the beginning or maybe a couple of years ago, Uber was fined for 148 million by EU. So the top line was a violation of GDPR. And then there was a $230 million fine from British Airways. And the most recent one was FTC versus Facebook. Facebook was fined by $5 billion. And the bottom is, of course, is a case happened just last year. FTC brought a lawsuit against Google YouTube, and Google YouTube did not send consent to children's parent for accessing children's data, right? So this is also kind of complicated because for minors, they don't have, even they say, well, I agree, you collect my data, but they don't really have, they don't have a sufficient ability to make such a judgment. So the consent should be sent to parents. Then this was, Google was fined by $170 million. So a very tricky situation here was some company, they would say, okay, I get fined by FTC or some agencies for millions of dollars. But on the other hand, because of the information, I can earn billions of dollars. So for some company, they would say, well, this is cost of sales. I don't know whether you have heard about this term or not. One example I can provide is like Google used PageRank in the beginning, and then they do this AdWords, right? If you can buy words on search terms on Google. And the patents of AdWords was owned by a European company. So if you implement it without licensing, then you'll be fined heavily. But if you want to license it, and there's a cost. So how can you deal with the situation, right? So that's when that happens. That's a consideration. I'll say, yeah, let me just violate it. If it's not working, then I just during this kind of disagreement or dispute, I can just drop it. But if I make huge profit about it, then I can just pay the fine because at the end I'm earning more than lose my loss. So that was very that kind of act was very non-ethical, but it's actually in practice. Okay, now we want to say you talk about all these compliance requirements. How can we implement it? And be very careful. There are many methods presented out there, but always on mind is one. Even a policy has been implemented, can private information still be re-identified, or people can do reverse engineer to find out who you are or which group you belong to, right? So that's one thing to consider. The second thing to consider is, again, the provability and trust, right? So you say you had done that, but prove me how did you do it and when did you do it? So the execution to comply consists of 5 steps. One is you have to delegate an oversight committee in a company. So this is just not say I have done it. So when FTC audits a company, my previous company was audited by FTC. So when they came in, they say, hey, give me all the documents to show you do have an oversight committee, who they are. And these people do exist, okay? And they map the data you have collected to your usage and storage. So where do you store the data? Can you show us the document and how the data has been used? So it's definitely hard for FTC to really get into your database to look around, but they want to see documentations. And then do you have this SOP for your employees, right? So all the regulation we talk about, do you have this compliance process for your data controller and also data processors? If, frankly, you don't even have a process in place, then everything is just talking. And do you have your personnel divided into DC and the DP, and also specifying their roles very clearly, right? And SOP for serving consumers. When consumers is served, did you really give them this kind of contract to sign, so allow them to opt in and opt out and comply with all these required items? And finally, provability. Let's look at the technical approaches. So the first one is very understandable. You say, I just anonymize the data, right? Then we have this differential privacy was popular before CCPA was activated, and the federated learning is still very popular. And Google was pushing that, pushing this effort, and quite a few papers have been published on this particular subject. Then finally, talk about distributed ledgers. So anonymized versus pseudo anonymization, there are some subtle differences. So anonymization means if I look at the data or a SQL table, I have no idea who is that particular person. So basically, you just hide all the personal identifiable information, right? So including, as I said already, your gender, your profession, and so on and so forth. So, but even let's say data has been anonymized, still could be re-engineered to find out who is a person. For instance, let's say cell phone will track my locations. So it knows in the daytime I will be in certain location around Stanford. So for sure, I think the Google Maps will say, oh, Edward is affiliated with Stanford University and he lives in Palo Alto, right? And from the duration I stay in a particular location, let's say I stay in the Gates building, but I'm not moving around very frequently. I'm at one spot for more than 1 hour. So easily to infer, well, maybe you are not a student, because a student will be moving around to different classrooms, but maybe you are a staff or a faculty member, right? So if you say, oh, every other days you will show up at a particular building and for about 1.5 hours, now I say, okay, it's more likely you are a professor rather than a staff. So see, you have not really disclosed any information explicitly. You only have this person's moving patterns, but already you got lots of information from this person, right? And another example is on Facebook, you say, I'm not going to give you any of my personal information, including my birthday and where I live. But unfortunately, if you have your social networks and you are interacting with people about 20 some years old, and they are college students, and most of them are from UCLA, it's not really hard to infer you should be in high probability you are a UCLA student, right? Then with other information probably not stored in that particular app, then people can identify you. So because I'm in this news business, when you do ads targeting, if you just use the user's news data itself. So I was joking with our engineers. I say, well, I read election news. Let's say I'm either pro-Republican or pro-Democrats. Just based on either I go to CNN or Fox News, can you target me with ads? Right? This is just ridiculous. If I'm a Democrat, do you sell me Tesla or do you want to sell me Ford? It's not very clear. So I say, well, news data, news reading history, using those to target ads, it's kind of ridiculous. But then all companies will buy information, data information from browsers, from other sources. And the Facebook information I just gave you, I was doing a search on Google. I was not doing a search on Facebook. I would never do a search on Facebook saying, oh, my knee hurts, what should I do? I did a search on Google, but how come Facebook will pop up this particular ad, right? So somewhere someone was collecting information, then they aggregate all information from all different apps, maybe through the browser or somewhere, then they aggregate and they target myself. So if you just look at one application, you may say, oh, I'm very safe, no problem. I virtually about everything. But when they collaborate with some other applications, then maybe RPI will be identified. So there are many horrible scenarios you probably can find on the internet. If a person really want to target you, find who you are, it's not impossible. So a basic practice is as following. Like I say, if you have a consumer's data, right, you want to say, I want to separate the data into two relational database tables. And in one table, I can store his or her name and the personal information or personal identifiable information, and then have a hash ID. Then using this hash ID, I can join another table. The key will be hash ID, unique hash ID, or you want to say maybe the hash ID may not need to be unique. So that's another way to make sure the data, you cannot target one person, maybe just a group of person. Then hash ID has then indexed to non-PII information. So the table, this second table can be accessed by a data processor. If they look at the table, they look at hash ID, they look at all this non-PII information, they are fine. They are not able to identify who is doing what, right? Only data controller, oh, he or she can join two tables to know, oh, this person with this hash ID is Edward. So Edward has accessed Facebook and Google in the last few days. So this is a very primitive way of try to be compliant, but for sure, it's not really in fully compliance. So the second method is differential privacy. This was proposed by professors in Hong Kong, UST. The idea was, I don't really need to separate your PII from your access history, but I just need to introduce noise to the data, right? In this example here, on the top, you see you have a very specific information about person, including office in London, department IT, date joint, 2015, and salary information, and so on and so forth, right? If you get a hold of this piece of information in a company, if you work in a company, you see this, it's probably not very challenging to infer who is this person. So you say, okay, I'm going to try to introduce noise. So rather than London, I say, well, UK, and date joint. I wouldn't want to specify the month, just the year. Then the day of birth, I specify, and then maybe just a decade or an epoch of time. But still, this is not bulletproof. So, but in theory, differential privacy is attractive because they can come up with a quantifiable method to safeguarding privacy. And you can see the formula is in the middle of the screen. The idea here, there are two parameters. One is this sigma parameter. So they have this sigma algebra. The sigma algebra is, I'm going to introduce to your data certain noise, right? So for a particular field, we already seen, you say, well, I'm going to apply this age expansion or birthday, kind of anonymize your year, but we put your day and month over there, this kind of algebra. And then they have these privacy parameters, right? They say, well, it's just like a nearest neighbor search. And so last time we covered nearest neighbor, but we didn't finish. We continue next time was when you do a nearest neighbor search, you don't get just yourself, you get a group of people. So then you say, I cannot really pin you down as a particular person in that group. So this epsilon means you can introduce this epsilon, and then there's a trade-off here for the company to decide. You see the left-hand side, the trade-off is, oh, privacy metric. So you want to safeguarding privacy, then the epsilon value need to be very small. But if you say, well, I don't quite care about your policy, I care about utility. Sorry, it's the other way. If you want to safeguarding privacy, epsilon value need to be large. So when you want to, when the information is given, you identify actually a lot of people, not just a small number of people. So it's hard to pin down one individual. And by the same time, it's utility metric. So if I get a whole bunch of people here, then this application, suppose I want to do a search, I want to do information dissemination, recommendation, then my accuracy, right, the application's target performance metrics will suffer. And for any company which needs to generate revenue, the revenue for sure will go down. So the question here is very, very simple. privacy is possible to be implemented, right? So you say my privacy regulation is very loose, and comply with privacy eventually can be kind of enhanced, but I'm going to lose a lot of revenue. Would the company do that, or would they try to do any kind of circumvention to prevent compliance? So this is a real problem, and that's the reason, again, provability becomes important. So let's come back to look at this differential privacy, and depends on how large the epsilon you want it to be. The privacy can be a local privacy or a global privacy. Local privacy means, okay, I have a small group of people. I just want to implement this sigma algebra, so magically alter their private data. Then I have an aggregator, and eventually I can store the data. But I can make my privacy slightly more global, means I have an aggregator. I already aggregate information from a large number of users, let's say female or male. Then I use a magic formula to alter them, right? So then I have this anonymized output. And because the input is a group of people, so it's much harder to track back to individuals. So when you combine both, right? Suppose I say, well, your private data, individual data, I'm going to do a shuffling. And then I do another layer. I analyze the shuffling results, and applying even more magic, then I really anonymize everyone. So the question is, let's say the final method is probably the most secure one, but it probably provides the business use that information to make their profit, right? So again, this is a big trade-off situation. So people trying to do this differential privacy, then I think it's kind of dying out. It's really hard to prove to an auditor saying, this is my epsilon, this is my sigma, so this is the way I conduct the business, and I prove in theory this will work. But no, you cannot prove. Everything is done empirically, and even you show their empirical data, and who can trust your empirical data? So Harvard published this interesting article. It's interesting, but it was not very sound. Basically, this paper saying, well, you did your differential or pseudo anonymization on the data, but we can re-engineering, re-identify the users, right? So the experiment they did was they get about 300 users data from the medical databases. Then they say, well, everyone was anonymized. So let's start to add additional information. Let's say zip code and date of birth and so on and so forth. At the end, they say, well, we can identify accurately about 90% of people. So I understand this is a kind of interesting result showing the more personal data you know about a person, you can more accurately infer who the person is. But this is no brainer, right? So the challenge to me was, if you only have 300 pieces of information, then you claim you can identify a person 95% accurately. I think it's an easy problem. But if you enlarge your pool from 300 to 3 million, and I bet even with a zip code, you cannot do that. And if you have date of birth here, frankly, even with 1 million people, the accuracy can still be quite high, right? So I respect the paper, but the paper itself didn't really tell me any promising or exciting methods. Okay. So federated learning, it started from 2017. Google wrote a paper and also a blog introduced the method. The method is very logical. So we all have our devices, our laptop or cell phone and whatever personal devices, and we don't send our private data to the app, to the cloud. So all data mining, all this kind of machine learning will be conducted on the phone, right? So after the machine learning has been conducted, a model has been learned on the phone, then the model will be sent to the cloud. And the cloud, or it's a centralized system, then will aggregate all the information and develop a global model. And the global model will come back in return, come back to this target individual cell phones. So on the one hand, this is kind of attractive. On the other hand, it also introduces errors to the classification. And not only introducing errors, but there could be other problems. Let's say, what kind of information you aggregate? Suppose I own the Android system or iOS. So the amount of data I collect is not just from one application. I actually collect data from all different applications. So as an example I gave you a few minutes ago, this is even more dangerous than getting all information from one application, right? One particular application. But you get all information, you get information from all applications, then you do kind of collaborating among them. And the kind of information you can collect is just totally horrible. And okay, let's look at healthcare as one example. Suppose I have a deep neural net, and this picture shows there are multiple layers, attention layers, and so on and so forth. And the idea of this federated learning is I'm going to cut off these multi-layer neural networks into two parts. Right? So my animation doesn't work, but actually the key thing is in the middle here. Let's say I draw a line in the middle here. Okay. Actually, this picture will show. So I have 4 hospitals. Each has been training the model based on their, let's say, X-ray data. They want to do this CT scan or maybe lung disease classification. So each hospital have collected certain data, then run their own training algorithms. And then I say, okay, I'm going to cut your neural net into a half. So the top half, so you learn in the middle, then I say stop. Don't continue learning. Just ship me all the model parameters. Then you say, okay, I'm going to continue learning here in my center database. So you guys stop learning. I'm going to aggregate, right? So at the bottom here, you show this is a centralized continuous learning and getting parameters from all different sites. And this method seems to be reasonable, but there are clearly 2 shortcomings from medical perspective. The first shortcoming is, as Andrew Ng said, every hospital may collect data using different process, different devices, or even same device with different process or calibrations. So when you aggregate the parameters in this subsequent model, those parameters may not agree with each other. And that could be problematic because each other will become your noisy disturbance rather than trying to help you. So for the text data, this method could be productive because a text is a text. But for imagery, this pipeline may not be able to improve your accuracy. And in practice, I see these kind of methods, it's really hard to be realized because no hospital here would trust other hospitals. Every hospital considers their own data to be a piece of gold. They don't want to share with others. So only perhaps on Android phone or on iOS, this federated learning can be conducted. But for healthcare, I have really strong doubt. Okay. So problem solved, and I don't think so. And the 2 key problems, one already enumerated, which is the trade-off between privacy safeguarding and the utility to the company or revenue of the company. Right? This is always an ethical problem, and a company, IPO, post-IPO company, they have obligation to their shareholders, and the CEO is under tremendous pressure to perform. So I don't know where the CEO would draw the boundary. The second challenge is provability. right? You can claim anything, but CCPA now requires a company to prove. So this is the picture to summarize regulations, but at the end, on the right-hand side, is you should be able to trust the company, and the company has to be able to prove their results and the policies. So let me spend the remaining time to introduce Soteria. Soteria is a goddess of Greece. It's kind of providing individuals safety. And the basic idea is we want to log everything, including user consent, user revocation, and so all the consumers' actions on their data and all these actions conducted by the company basically need to be hardened on a ledger. And this ledger, if you want to be able to be people to trust the ledger, this ledger need to be open, transparent to the public. So anyone can audit the ledger. If I say, no, this is a centralized system. This is the bank's ledger. So you can, I'm going to log everything, but sorry, I cannot allow you to come in to see the details because I don't want you to see other people's account balance. Then this is a ledger which is not transparent and cannot bring people's trust, okay? So transparency is the key. So that leads to the centralized and versus decentralized system. The centralized system, by the name, basically saying all the data, all the synchronization is conducted by one unit, right? Let's say a central bank or all the banks in the US, they have this bank, the headquarter bank, and all information need to be synchronized with the headquarters. So when a bank want to close their books every day, they have to synchronize from the center to all the distributed bank branches to try to reconcile their books. And decentralized means all individuals can communicate with each other, and you can do local decisions, but eventually we need to be able to reach global agreement, okay? So we come back to see an example. This is a centralized banking system, deposit, withdraw, and so on and so forth. Let's say I have two ATMs. I'm using two ATMs. From one ATM, I deposit money. The other ATM, I withdraw money, right? So the important thing is you need to be consistent. You cannot say, well, before my deposit goes in, I already withdraw my money. So I have this kind of double deposit, whatever, this kind of scenario. And in a Bitcoin situation, they want to safeguarding double spending, right? You say, I want to use my Bitcoin to buy $10 of goods in one company or one store, use the same Bitcoin to buy another thing. So there's a window about 30 minutes for a Bitcoin transaction to be committed. Within the 30 seconds, a person can double spend, and that problem has to be closed, right? So, but Bitcoin is a decentralized problem. It's much more challenging than centralized problem. But centralized problem bank is one example. And another example can be hospital. So you say, okay, I'm going to perform certain process on a patient. The information will be stored in the hospital, but eventually the information had to be sent to who? Sent to a payer, right? Sent to an insurance company. So insurance company pays the bills, and they pretty much aggregate all the data together. They have all hospitals' data. And this is pretty much universal. In Canada, they have universal healthcare run by the government. The government has to pay the bills, so the government has all the healthcare records of the Canadian citizens. Now, again, the question is trust. If you have a centralized system, how can I trust you? Because you are not going to reveal me all the actions you have conducted. So we like to be able to have a decentralized system. So decentralized system, the question then will be, you have certain inconsistency that will happen. You have local agreement, but globally may not be agreeable. So therefore, consensus protocols need to be executed. So consensus protocol can be separated into two camps. One is distributed consensus. You could have local consensus, eventually you converge to global consensus, or you just have a centralized consensus protocol. And centralized consensus protocol has been out there for many, many years because banks or airline reservation systems have been out there for more than 2 decades, right? For airline reservation systems. And when they started about even 20, 30 years ago, even today, they haven't been able to really changing the system because it's just too many agents try to access the database, and any modification to the system run into the risk of data corruption. So without getting into all these protocols in details, because we want to stay on a high level, and the Stanford has courses to cover the detailed methods. And when I was back in the CS department 20 years ago, there was a database course, then there was a transaction processing course. And the transaction processing course will cover all these protocols to safeguarding agreement. So let me just give you an example. This is a rudimental consensus protocol called two-phase commit protocol. So I have my participants, right? And eventually I need to make a decision. So let's say I want to have a consensus in a class to say, when are we going to do this is hypothetically, when are we going to do our final exam? And then I send out 2 dates. One is next Tuesday, another one next Thursday. Then students start to vote, right? So once I get all the votes, I say, okay, majority people vote for Thursday. So I would say, I will return back to you to say, okay, now I'm prepared to commit because our rule is majority wins. And then the decision phase, the student will say, yeah, I was saying Tuesday I prefer, but now the kind of a majority decision is Thursday, so I'm going to, okay, commit. I'm going to decide to commit. So you have second phase of communication. So in the two-phase commit protocol, here you see the overhead is the number of messages going back and forth to reach consensus. And if the number of participants is small, and you have this kind of centralized system, and the cost is linear to the number of participants, right? Say I have 10 students, and maybe the message will be sending back and forth 40 times because the two-way messages for each phase. But then when you say I want to do a global but decentralized kind of commit protocol, then the cost will be much, much higher, will be n squared, right? So everyone has to be able to talk to everyone in the most general situation. And this is not affordable. Then you say, well, on the one hand, I want to be transparent. I want each person to be able to make their kind of own decision. They can look at other people's data. But on the other hand, I have this kind of enormous cost. How can I mitigate or I do the reasonable trade-off? And the trade-off, easy to understand here, is I'm not going to talk to everyone, although I want to do decentralized system, but I'm going to talk to just a group of people, right? A group of people who I can trust. Let's say when I want to make a commit decision, or when I say I want to sell my medical data record to Sahil, and this agreement only need to be approved or been seen by, let's say, AAA, Bank of America, and maybe Tesla. Only 3. Because why? I don't think they together have any interest to conspire together to kind of hurt me, right? So I say, okay, that's good enough. 3 participants to vote for yes, then I can move on. And so this is a kind of compromise, but also reasonable, right? But if you say I'm going to randomly select a few, then the situation will be much more dicey. So just slightly talk about the Bitcoin situation. Bitcoin is entirely decentralized. And they say, oh, if 2/3 of people voting saying your transaction is hardened, just an example, or when they start to build new blocks, right? So when the new blocks has been granted, has been committed, they have this kind of longest block will win now this condition. So you have a block which is 6 blocks longer. You have a chain which is 6 blocks longer than the other chain. Then all the previous blocks will be hardened or will be granted or be committed. But this will take some time, right? And they don't actually identify who are the people who can make a block committed. So it's like racing. You have to solve a puzzle, and when a large number of people solve a puzzle, then the block is kind of hardened. And so who can solve the puzzle is random. And let's say even you say 2/3 or 1/2, the people in this 2/3 and 1/2 pool, they are random. You don't know whether they can be trusted or not trusted. So eventually, some powerful kind of resource company, they actually can hack down Bitcoin because they can own the majority of GPU in the world, and they can be the majority of this kind of voting scenario, right? So instead of doing that kind of so expensive computation, why not just saying, oh, I'm not going to send to 1 billion people. I'm going to get these 10 people, right? These 10 people have conflict of interest with each other. If they all say yes, then that's fine with me. So that's pretty much the idea between a centralized, decentralized, and decentralized. You have this n square messaging cost. And n square messaging cost is huge because I/O is much more expensive than CPU or GPU time, computational time. So that would just grind your system to a halt. Again, the trade-off will be, okay, I'm not going to talk to n. I'm going to talk just a small subset of n. So this decentralized picture shows the trade-off between cost and the trust, between transparency, again, and the trust. And there are so many different protocols recently got proposed to be able to achieve a very good compromise between the two. So what do I say? Good compromise really depends on the application's objective. Okay, I can again give you a couple examples shortly. So consensus versus transparency. In the privacy situation, all the actions like what kind of data I allow the consumer to be processed by the business, and the contract, opt-out information, rectification, all the information need to be transparent to the public so can be audited. And using blockchain to solve the problem, first of all, let's quickly identify the structure of blockchain. So a chain of blocks, let's say h is the height, means I have h individual blocks. And every block may consist of a number of transactions, right? In the transaction is in the sense of bank is straightforward, deposit and maybe withdraw, or I look up my account history. In the case of privacy, every transaction is like, oh, user A's consent, user B's revocation, and business A access user B's data, right? Those are the transactions upon your data subject will all be logged on the blockchain. So this is one example in one single block of the chain, and the transactions are organized into a Merkle tree. So the characteristic of Merkle tree is if you change one of the leaf, and then the hash value in the Merkle tree will be modified. So why we call this indelible? Because no one can come here to hack your data. If someone did, then the hashing value will be mismatched, and we can identify. And then this is like a binary tree, eventually going up to the top, and we have this root hash, which is utilized to authenticate this block is not contaminated. Then this block has a hash index to the previous hash block. So when we index all together, you can see the blockchain has a number of blocks. They are linked together with this kind of previous head address. And every block has a number of transactions organized in this Merkle tree. And it's very evident why you only have a pointer to the previous block, because you have no idea when you establish a block, you have no idea when the next block will be established. Okay. So key requirements here, I'm not going to repeat transparency and the privacy and probability. So now let's step back to see how the blockchain can be utilized. efficiently. Because I talk about Bitcoin, and you know Bitcoin very well, the problem is latency, right? Latency of Bitcoin means I need to trust a transaction, but I need to wait for about half an hour, because unless the transaction, the block which the transaction resides get committed, and in addition, that particular block resides in a blockchain which has a length 6 more blocks than the second longest one, then I would say, okay, my transaction has been hardened, and this will take half an hour. And this is a pretty long time. If you want to do this half an hour transaction, then payment is impossible. You do payment, you go to Starbucks, you say, I'm going to use blockchain to pay my bill. The commit time is 6 hours. So I think Starbucks wouldn't accept your payment. So like privacy or like currency, if you want to use this kind of Bitcoin methodologies, something has to change. And this is the way we did it. So before we get into detail, let's look at this Eric Brewer's CAP theorem. CAP, C-A-P, C stands for consistency. So data viewed by different parties need to be consistent in the same order, right? It's like I withdraw, then I deposit. Other people look at the record, they want to see withdraw deposit, they want to see the other way, then you have this inconsistency problem. Availability is another one. You want the system to be up all the time. So this is like the cell phone networks. So if I shut down my cell phone now, it shouldn't affect your cell phone, right? It's very easy to understand because you want your cell phone to be available, not depending on other people's cell phones. And the partition tolerance. And in the banking system, partition tolerance is not allowed. But in our cell phone scenario, general network scenario, internet, partition tolerance should be allowed. Otherwise, if my laptop is down, your laptop need to be in a standby mode. That's not acceptable. So if we look at this picture, then we say, well, in the internet era, if we want to do a distributed system, there's one property we cannot sacrifice, right? Which is partition tolerant. Okay, we have to safeguarding this partition tolerant property, which is P. But now, since Eric Brewer theory is saying you can only ensure 2 out of 3 properties can be guaranteed at simultaneous at one time. So either you choose CP or you choose CA, a PA, or only 2 out of 3 or CA. The banks choose CA, right? They don't care about partition tolerant. If there's a partition, they shut down the system right away. They guarantee consistency, and when the system is consistent, they open up. They make sure it's a scalable, available. So decentralized system, as I just summarized, we need to provide people just either CP or AP. For the sake of Bitcoin, they provide this A and P because Bitcoin want to be available all the time, and they want to also allow a network to be partitioned, but they sacrifice consistency. As I again just mentioned, we think about 6 hours or half an hour, depending on the situation. Your transaction was in an inconsistent state, so double spending could happen. And summarize Bitcoin's problem. One is it's very expensive to maintain such a blockchain, and $1 billion a year, and the lack of privacy. Why? Because you put data on the chain. So now you say, Edward, are you kidding? You want to put medical data on the chain, so you want to put medical data in the public. So I will come back to address the issue shortly, and use a POS, proof of work protocol. Means you want to solve a puzzle, and nuance is very expensive, and finally low throughput, right? Transaction per second for Bitcoin is only 7 transactions per second, and Ethereum is 15, not much better. So if we utilize that to be a payment, that's impossible. And if we want to utilize for security, privacy preservation, that's kind of also not very convenient, but we can solve the problem. So banking, I talk about the centralized system using CA. And we also already discussed the trade-off between centralized and decentralized consensus protocols. And then let's look at Soteria. How can you implement a system which is at the same time can ensure this AP kind of property, also can ensure PC, PC and PA at the same time. So PC and PA, if you union the two, it become PCA. The trick here is we want to be able to achieve short latency, like 1 to 2 minutes, and the throughput need to be extremely high. And we are arguing, this is actually argued by Professor Majerus. Professor Majerus, by the way, he was one of founders of Stellar. Stellar already IPO'd. It's maybe number 8, the public IPO company on blockchains. And he and us had many interesting debates. So basically, I say, okay, let's have this 2-layer blockchain. So you have main chain ensures AP properties. In the worst case, main chain is Ethereum. It's in the public domain, but the side chain will be on the CA using CA property, right? We are using CP property is also okay. So the side chain will be very quick, but the main chain will be very slow. So this is the picture. Our side chain, let's say, even using CS system, the main chain is using this AP system. We organize them into 3 layers. The first layer is a public chain with very slow response time and high latency. And the second layer with very fast execution time, low latency, and high throughput. The method to improve throughput is like David Measure said, you just replicate your CPU, right? You just duplicate your local system. And I only care about latency. You want to guarantee latency. Then when you want to guarantee throughput, if you have sufficient business, you just replicate your system. So that's a claim by Professor David Measures, and we have to agree with him. And finally, you have this smart contract, which is the way to not to put data on the blockchain, but you put contract on the blockchain. Even more beautifully, the contract is in natural language. So if you say I put something on the blockchain, which is my private data, is really bad. If I put a digital contract, which is a piece of code on the blockchain, in fact, we will be eventually put a piece of code on the blockchain. Let's say I want to access your data, and this is an agreement in natural language, but we need to be able to convert this natural language statement to a piece of RESTful API or SQL statement. Let's say fetch something from relational database K with attribute equal to what, right? So with this particular piece of code, but already approved, then certain people can just execute the code to get your data. So smart contract is a very important piece of information sitting here for 2 reasons. One, through natural language, user can understand what they are up to. Then we convert the piece of information into a piece of code. And this conversion, I pretty much covered when I talk about OVO, right? We had a lecture about this human voice speech interface. And in that, I talk about in OVO, and we need to do semantic grounding. Semantic grounding, in principle, is very challenging. But if you want to just grounding to programs, it's much easier because programs only have a small number of instructions, and also they are not ambiguous, right? In natural language, a word can mean multiple meanings. You have polysemy or other situations. But in code, when you say right, it's right. When you say move, it's move. So smart contract is the good solution. So smart contract, summarize it, it's a piece of natural language construct to convert to a code, and the data is offline, retrieved by approved code. And the contract validation, revocation, execution will generate transactions, and these transactions will be written onto the blockchain. So when you look at the blockchain, you do see, oh, I have a piece of code executed, but the code number is 722. You have this ID, and then you have transactions to form a tree, and the root of the Merkle tree on the subchain right? We say subchain will be very efficient, but you say, okay, I make the subchain very efficient, but the root of the Merkle tree, I lock it to the main chain. So when I lock the secondary root to the main chain, the process will suffer from low latency, but it's okay, right? Because I can locally guarantee the transaction has been hardened, but probability can be guaranteed maybe half an hour later. So this is acceptable to the private situation, because even I want to sue a company, I cannot file a lawsuit within half an hour, right? So I do have half an hour. Probably, if you want to contact a lawyer to file a lawsuit, that would probably take a few days. So this hierarchical architecture is just beautifully can accomplish the objectives. To summarize, we have this on the side chain. We have hash blocks, and they got linked together, and they enjoy the performance of high throughput because you can replicate the systems, and more importantly, low latency. And the privacy is safeguarded because we don't store data on the blockchain. We only store the ID of the code on the blockchain. Data is in the database, access to the code. And then we hash the root of the local Merkle tree to the global blockchain. So when the public auditing is conducted, they can go back to the global blockchain to verify the local Merkle tree hash value is not altered, right? This ensure authenticity. So this picture just to complete. When we implement a system, we still need to have a reasonable user interface. If you like to know the details, you can look into our publication available on the internet. Let me get into slightly more details. Say on the left-hand side, right, you have interface here. Both data consumer, data provider can access through the web, and the data provider, let's say I'm a patient, I can say, okay, I have a data, my X-ray, I'm willing to sell my data at the price. And data consumer comes in to say, this may be a pharmaceutical company saying, I like to be able to bid 20 pieces of data in a particular situation. Or I say, I want to do IRB, I want to do some kind of drug discovery or vaccine test. I need to recruit 10 million people or 10,000 people. I can go through the system to say, who willing to give me your vaccine drug interaction or side effect data. So then this agreement can be conducted through the web application. So once the consensus have been performed, then the data will be stored, right, into the database. At the same time, the blockchain will be also locked on the blockchain. And then when the audit comes in, the bottom is the audit. Audit comes in, you can look into the local database, which caches the blockchain's information. And right away, I can say, well, the company already fulfilled your requirement, and this is the information I can give you right away. And the response time for this ATS cache can be just within seconds. Then they say, no, I don't trust you. I want to go to the core to verify. Then the core will not access the company's private data here, stored in the cache. The core will go to Soteria, which is a transparent public ledger, and the court or auditor can go there to access all the transactional information. And this is a picture thanks to Professor David Measures, Monica, and Shiwei Liao in NTU. And we try many different local protocols, and eventually we identify Stellar and Tendermint. Those are two good protocols we can employ. And there's a very strong argument from Professor David Measures. He's a no-nonsense guy. He said, why do you guys want to use blockchain? Because I can see this entire system can be implemented by a log-only method. You just log, right? You just logging. Why do you need to ensure consistency in this whole thing? This is not payment. And we do have a very good counter-argument. That counter-argument ceased his concern. So if you have time to think about it, why we need to have consensus on consistency on the order of transaction in the privacy preservation scenario, yeah, it's an interesting question to think about. So we is some experiment we conducted, but the details again refer to our publications. So summarize today's lecture. Privacy is very critical. If you started a company, you want to be able to consider privacy before IPOs, right? All the lawsuit wouldn't come in when you are a private company, but when you go public, the next day you see a number of letters from lawyers. And complex requirement and also some solutions, they are complementary, right? You can use them in a combined method, but at the end, probability, transparency, they must be safeguarded. And with this, concludes today's lecture. You have questions, please ask on the Slack.
And this concludes the lecture today. And tomorrow I'm going to host an office hour as scheduled and announced. And then next week, we look forward to seeing your project presentations. And thank you and goodbye.